Our last presenter is Anissa Stull with Redwood Energy. And hello, Alani, will you introduce her?
I will. Anissa Stull of Redwood Energy has conducted research on various decarbonization technologies in both residential and commercial spaces. She has worked on the heat pump water heater heating for Redwood Energy's commercial retrofit and is currently working on the power optimizer calculator for Redwood Energy. She is a recent environmental resource engineering graduate from California Polytechnic University, Humboldt. And today she'll be presenting on the electrifying multifamily homes without upsizing the electric panel, the power optimizer calculator.
Yay, Anissa. So this is, she had to record this just because she wasn't able to make it today, unfortunately. So just so you know, it's pre-recorded. And we have been calling this calculator, which is the National Electrical Code. We've been calling it the amp diet, the watt diet, and the power optimizer. They're all the same thing. We're trying to just find a name. So with that, Anissa.
Hello, my name is Anissa Stull, and this is Electrifying the Home Without Upsizing the Electrical Panel, the Multifamily Watt Diet. So what is the Multifamily Watt Diet Calculator? Essentially, it is a tool developed in Excel that calculates or estimates the size of the electrical panel needed and whether or not it needs to be upsized to electrify a building complex. So this calculator utilizes the National Electrical Code to make sure that's remaining in compliance. And I'm not too sure how many of you are familiar with our single family calculator, but it is modeled similarly to that. However, the differences that make it multifamily is that a multifamily dwelling equates to 3 or more dwelling units. Specific demand factors have to be applied to multifamily buildings within the electrical load calculation. In addition, multifamily calculation methods include the standard and optional, which I will go over in the next slide a little bit more. And multifamily dwellings contain central loads and common areas. So what is the standard and optional method and what is the difference? So standard method is a little bit more of a lengthier process. It applies a lighting demand factor to a minimum feed loader to find the feeder neutral load. And per the 220.61a, the maximum unbalanced load is the maximum net calculated load between a neutral conductor and any one ungrounded conductor. The optional method is a little bit shorter, about a 3-step process, and it is the preferable method if possible. It uses the demand factors from 220.84 and will always yield a smaller load. If you're not sure whether you can use the optional method, it does fall under these 3 circumstances. The unit must be supplied by more than one feeder, equipped with electrical cooking equipment, and equipped with electrical and or AC. So once you download the calculator, you will be kind of met with these 7 tabs to go through. This includes the cover sheet, user inputs, summary, appliance configuration, central loads, HVAC, and demand factors. I will be going over the more user input extensive ones. Tabs such as cover sheet and demand factors are kind of read-only and just referenced in calculations that is used within the other tab. But the first tab that you will be using is the user inputs. This includes 3 tables that you can see here. So moving from table 1 to 3, the first table is basically summarizing the unit type of bedroom count. So if you have a studio, 1 bedroom, 2 bedroom, etc., and then you would input the number of units, floor area, and then this is where you will tell the calculator if the laundry or hot water is a central load. And then you would then choose which appliance configuration type you would have it fall under. There is multiple appliance configuration tabs. This just lets you basically choose if 2 bedroom types or bedroom counts had a different type of watts or power coming into, like say the fridge or whatever. This would just allow you to be able to calculate them on different tabs. The second table is a summarization of the central load types. So you have the laundry, heat pump, water heater, elevator, etc. And then just a quick description and then the number of units in place. So say you had 20 dryers, 20 washers, and then you would input the volts and device amps. And then the final table in the user inputs is basically just to help you understand or know if the optional method can be used in your specific building complex. So you would answer these first 3 questions with a yes or no, and then that last column or row in the table basically uses logic to tell you whether or not the optional load calculation can be used. So then the second tab you'd be met with is the summary tab. This is containing both the optional and standard method calculation results. This is just kind of giving a visualization of the differences in them. You have the load type there on the left, and then you would input whether the laundry is in unit, central. You have the baseline loading or baseline lighting, demand factor units, demand unit, etc. And then from here, it would calculate the transformer at 240 volts, which you're seeing at the bottom right of each of these, and so forth. And so the appliance configuration tab is a little bit more user input heavy. So starting from the top, and then we'll go to the table that you're seeing on the right, you would input the utility service volt, and then the utility panel amperage, and then it would auto-calculate the base energy use in watts. And then from there, you would enter the specifications of the different type of devices that you have within the building. It's broken up into laundry, kitchen, heating, etc. And then from there, it's broken up even further into, fridge, garbage disposal, etc. You would enter the watts here, and then it would automatically calculate the device watts, which is before the coincidence calculation. And then it's also giving you the typical power and low power. This is just, say if you were messing around with it a little bit and you wanted to see if you were to input like a low power washer, how would it affect the building that you have currently? But then from here, you have that table on the right, which is the panel watts table. This is basically just giving you a summary of the base load watts, heat pump watts, appliance watts, which you inputted on the left. And then these bottom 4 is basically the final calculation, giving you the total panel watts, the total panel amps, and finally that minimum panel size and the allowed watts. And so this is the central loads tab. This is basically just giving you an organized view of the central loads, and it applies the demand factors automatically. So within that summary table, you already inputted your central loads, which you can see like the laundry, washer, dryers, pool, elevator, etc. So this will already auto be in there from what you already input in the summary tab, and then it'll auto calculate the coincident amps, giving you that total central load that you can see on the bottom. So how are we able to apply this watt diet to real life applications? The Palm Desert apartment complex, they were getting feedback, or they are getting feedback from their utility that they are limited on the amount of power that can be supplied. And so our objective was to optimize the apartments to minimize the demand calculated. So just to give like a background on the building complex itself, the Palm Desert apartment complex is a 150 unit multifamily affordable housing project. It consists of 8 apartment buildings that are 3-story and 1 clubhouse / recreational building that is a single story. So just working through that calculator that we saw a little bit earlier, this is the user inputs that we used for the plans that we were given for the complex. And from there, we were able to input, the watts and the electrical load calculations that were in there into the calculator to kind of get a base case. And from there, we are going to be able to work and kind of mess around with the watts and etc. to figure out, how can we minimize that amount of power that's used. So as you can see, we use the user inputs. The building only has 2 or 3 bedrooms. and it has 111 of the 2-bedroom count and 39 of the 3-bedroom count. And then we load it in the floor area and etc. And then the laundry and hot water is a central load. And then you're able to do that appliance configuration type again. And so this is a little bit more filled out. Table 2, which has the central load. So they do have laundry, and you're able to split it up between the washers and dryers. And then it has the heat pumps and the elevator. There is no elevator, so you're able to put none. And then parking lot lighting, hall and stairwell lighting, etc. And then inputting the volts and device amps again. And then from that third table, you can see that the optional calculation can be used. So then this is the optional method that we used for this building complex. So we were able to put in the baseline lighting for the 2-bed and 3-bed, and then it auto calculates the demand factor from the demand factor tab using logic statements, and then number of units, demand unit, demand per unit, etc., and finally giving us a 3000 amp transformer. So this is the appliance configuration, which gives me the 208 service volts and 10,000 base energy use. And then we were able to input the amount of power that's used for the garbage disposal, dishwasher, kitchen hood, etc. Finally giving us a device watts of 17,855. And then you can see from the panel watts that the minimum panel size is 50. Keeping in mind that this is for 1 unit, just for example reasons, but within the actual plans, it would be 12 units, so it would be a little bit scaled up. And then finally, this is the central loads that we were able to calculate the coincident amps for. It has the laundry electric washer we saw before, the parking lot lighting, hall and stairwell lighting, finally giving us a total central load of 62.4 amps. But that was essentially what we were able to do with the watt diet calculator, is basically just get a base case scenario for the as-built and the plans that we were given. And then from there, we were able to kind of input maybe lower power appliances for washer, dryer, or heat pumps, and then kind of see how that affects the amount of power that's going to be used, and etc. But that is essentially the watt diet calculator in a nutshell. Thank you so much for listening.
Okay, woo! Yay, Anissa! So that was the first time I'd seen that presentation, and I just need to share with people that the backstory that Anissa was mentioning, that there was the utility had said that we were power constrained. Specifically, they said, you have 150 apartments you're requesting, we have power for 59. And what she just showed, I like got so excited, is because her conclusion that a 3000 amp transformer was what we needed, that's actually what they're able to provide. But the calculations that were being provided by the electrical engineer had almost 3 times that amount of power. So this process that she just walked us through is going to allow us to build 150 apartments in the Imperial Irrigation District utility territory. That's huge. That's all affordable housing for low-income families. And in that specific situation, the local utility just given away the last of the power, they said, to a ice rink in the desert, which is not for low-income households. So anyway, I hope you all see how important it is for us to be able to have a useful, user-friendly calculator. Yeah, thank you, David, and thank you, Philip. Yeah, and Anissa's been working on this for quite a while, and she's a brilliant young engineer. I'm really excited to get to share in her company. And just to mention, in this, you've seen that we've been affirmatively recruiting. She was also affirmatively recruited. She's the secretary of the Black Student Engineers program up on campus before she graduated. And we reached out specifically with a solicitation, try to recruit Black students, engineers, into our company. And we started with 4 students, and 3 of them ended up getting other situations or jobs, and Anissa is with us, at least so far. She's so good.